Hello, everyone, and welcome to this month's Python Exchange. As you all may know, this event is all about sharing practical knowledge, real-world experience, and useful tools from across the Python community. Whether you're here to learn some Python, ask questions, or just see what others are working on, well, you are in the exact right place. As per usual, we are joined by a group of host panelists whom we will introduce shortly, right before our panel starts asking questions for our guest panelists. The most important thing that we are here for today is our guest panelist, Guillaume Lemaitre. He's the Chief Machine Learning Officer at Probabl and a core maintainer of Scikit-learn, skrub, skore, and imbalanced-learn, and holds a PhD in computer science and medical imaging. Today, Guillaume will walk us through recent tools in the Scikit-learn ecosystem, going beyond modeling with the classical .fit, .predict methodology, tackling things like complex data prep, experiment tracking, and deployment. With that all being said, if you have any questions you want Guillaume to answer, please do use that Q&A feature. And I would like to go ahead and turn things over to Guillaume so we can get started with today's presentation. So Guillaume, take us away.
Yeah, thanks, Cameron. So I'm going to share my screen because I have a couple of demos to show. And here you go. So how can I just hide these things? Yeah, that's okay. So I don't need to make an introduction. You did well. And basically, I will spend like 20-25 minutes speaking about what we did recently in the ecosystem around machine learning. And to start with, I will just like make a short introduction of Scikit-learn and mainly point out the stuff that we don't like anymore or that we would like to change, and somehow what are the new tools and what they try to cover and to integrate with that ecosystem. So quick example, just like to see where we stand in. So Scikit-learn is a great tool for machine learning and usually tabular learning. So let's say that we have a table where columns are features and rows samples. Basically, what we try to do is predictive modeling. So for each of those rows, we try to predict basically a value, which is a target. So here, that would be the median house value, for instance. So Scikit-learn provides tools to have mathematical blocks where you can transform the data and then learn basically a mathematical function that links those features from one side and this target from the other side. So just to give a quick example of what we could imagine here is the following. So for instance, we can make complex pipelines, which at the end of the day require quite a boilerplate code to create, like, say, we want different columns to go into different preprocessings, and then to combine everything and then basically craft the feature engineering that we want, and finally pass this into, let's say, a machine learning models. So it's already one like pain point that we can see is that to do simple things, sometimes you need to already write like pretty much a lot of code, but you are in charge and you have the freedom of doing everything that you want. And so first you can craft your predictive models, and afterwards we give you the tools to be able to evaluate it properly. So usually with cross-validations. So for instance, if I run these examples, we'll take care about like the different split that you need to do, and then you get a bunch of results, and then you can use your pandas, the pandas library afterwards to make some aggregations, compute the mean and the standard deviation of some statistics, and like come up with some conclusion out of it if you model overfit, underfit, or whatever. We as well provide a bit more tools sometimes to get like, let's say, visual cue. So here, this is an example of, for instance, you have this display that will take the Scikit-learn estimator and potentially some data. And then you want to evaluate every like estimator from the cross-validation to be able like to get some insights. So we do a bit of processing this way. And usually let's say one later step is you want to tune as much as possible every parameters of your model. And Scikit-learn allow you to as well like do this type of thing. So for instance, here I could make a bit more complex the pipeline. So I can So basically that's the same pipeline, but I can introduce like a randomized search where I can define with this ugly naming here, which parameters I want to tune and basically make like with a budget of time trying like which combination of parameter works better. So if I have again some things to complain about scikit-learn is that because of how we design it at the beginning, then with the complexity of all those blocks that come together, tuning parameters is not the easiest thing that we can come with. But it does the job. You have all the blocks that you need. And potentially afterwards, so here I'm just loading from the disk to avoid to have like computation for spending time for the full computation, but somehow you can drive like the same type of conclusions and, for instance, afterwards inspecting your models, finding parameters, which combination works if you model like the parameters are stable or not, and those type of analysis. And usually that would be, let's say, like in a brief way, like in the simplest way, what potentially a data scientist would do. But at the end of the day, then you want to go into productions, and usually we just say, okay, persist your model with something like Probabl that will just pickle the models, and then you go on to the production side, and hopefully if you have the same environment, you can just unpickle and start to predict data. From those, so I just want to point out like what is good and what is bad from there is like scikit-learn is pretty good because you have a good API. And the API is not restrained to scikit-learn. You have tools that are compatible with it. So at the end of the day, when you do machine learning, you have like a good ecosystem around that. We take care about providing tools which are general enough by nature that you can apply on different type of programs. We provide you tools to evaluate and inspect models. And we take care about that the algorithms are fast until certain points, like when it's going on the CPU, and that the implementation is robust. And we come as well with a part of the documentation that should help you at getting your way around those different tools. As well as a pitfall, because scikit-learn is very generic, sometimes you just need to assemble everything, and everything rely on the know-how. So you need to be a bit of, an expert or like having knowledge of to assemble those pieces and to know that you don't want to make some methodological mistake. The documentation will help you towards this, but we don't have any mechanism that force you necessarily towards the good directions always. And then we have other like things that I didn't show here, but here I already show something that we have one data set and one single target, but in real world, you can have many tables that you want to aggregate, and usually you can use pandas or poras for that, but there is like issue with this that I will discuss in a moment. And the real world is much more like complex than just like one table, one vectors, and that you put in the models. And on the security programs, I spoke about speaking, so I will come back as well on this. So probably we can make a bit of improvement regarding like the security of persistence of model as well. Okay, so what are the different tools? So I have basically 3 tools that I want to show. So 2 of them are kind of already ongoing since a couple of years, let's say now, and one is very recent, like a couple of months. So the first one, I will give an overview because I think that Guillaume Lemaitre came to that meetings 2 sessions ago and presented that tools. So I will just re-go there and just pinpoint what does it solve as a programs, but without like spending a huge amount of time on details on there. But so this tool is called Scrub, and as maybe the name suggests, is that we're interested on whatever go from like the data sources, so where the data come from, up to the point or where machine learning starts. And one of the main ideas that we want to bring here is to bring back the machine learning models and bridge the gap to basically databases, if I want a simplistic view on this. And as a first steps, the first thing that we want is to help as well a bit on the data explorations. So not covering whatever pandas or polars tools can help. I mean, I'll help you every day with. It's more like, can I have like just like a simple function that already can give me the insight that I might need to make choices inside the modeling for my predictive models. And these first tools, I will just like show it here, is we provide these table reports where you can provide like a pandas data frame inside or polars data frame. And from there, we start to compute like a couple of statistics that somehow are like the barely minimum that you need to look at usually when you do modeling. So here you get a view like pandas would provide you like in as representations, and with a couple of add-ons regarding the distribution of the feature or like the unique values. You have a specific tab with all those information that you can quickly go on and, for instance, see the distributions, see different statistics regarding the distribution as well, potential outliers. We have a stat views that give you as well like a bit more information about like the D types of objects, the null values, and the unique values, and basically what pandas would give you with a describe in some way. And finally, we have something about association, which is kind of nice to have to know if you have like very correlated feature or not. And it can already like quickly like give you some inspiration on if you want to make some specific type of preprocessing in your afterwards during the crafting of your predictive models. So it's quite limited, but this is like a very synthetic views of what would cost, like in a simple line, it will cost you a bit more to do that in pandas. I mean, it will, again, because pandas is maybe well crafted here, it will like take you like 10 lines of code to get your head around, and maybe a bit more when you come to associations, let's say. So that's the first thing. It is more about the EDA, but afterwards we want to complement basically the machine learning part. And in Scikit-learn, we have a couple of preprocessing that could be like introduced in the pipeline, like what I showed before. But there's stuff that we don't care so much yet because we are not. Data frame is not the first citizen in Scikit-learn, and then some feature never have been like developed or would take times to think. And we thought that in Scrub we could like introduce and use basic Scrub as a place to find the right API for what we want, and then like deliver and be compatible with Scikit-learn, and people could use those. So for instance, as an example, we have encoders that could take care about like date times values, so convert basically dates at some places, and then, for instance, encode the dates in a specific manners. So here, just making like split day, months, etc. In the same spirit, we could have we have like a lot of work on whatever is categorical and what we call, I mean, messy categories. So for instance, when there is like a misspelling between different categories, but they are close to each other, so you would like an encoding that make embeddings that represent that specificities. So we have like a couple of encoders inside in this spirit. And all of those is just to show that basically you can go from string to numerical representations. And all of those are just like available. And at the end of the day, what we want is to provide an alternative of what we call the column transformer, where you need to create those building blocks for yourself, and instead to provide you like in one-liners building blocks that come to treat basically different type of data just based on the data type of the data frame. Then we will dispatch those on those different preprocessors. So that's the idea of the table vectorizer. And we push a bit further the spirit of this by adding helper function that can give you not the model that you want at the end, but good baseline out of the box. So if you are interested to basically, depending on the type of models that you put inside that you have at the end. So for instance, if I want a linear models, I will have to make choices basically on the table vectorizer. And out of the box, basically, we detect what type of model you want and make choices that are good default choices for you. And if you put like a tree, basically we will make different choices. So here, to give an example, if I put linear models, a rich regressor basically doesn't handle missing values. So you will need to like take care about the imputations. We will have specific parameters for the datetime because somehow we will apply some spline to be able to take interaction between the feature there. And we need to scale the data, etc., etc. On the other side, for a tree, we'll make a completely different choice because gradient boosting out of the box will handle a lot of specificities. And the good part is that you get a model which is normally working pretty good, and you can directly go in the consolidations steps and get like quick results. And this is a very like good baseline to start with to know if you have signal inside your data or if you already want to go back, for instance. So that's like the first part of Scrub. And then there's one that is what happened between those preprocessing and before. So it's like, I assume Gael presented this a bit, but somehow it's like, if I have multiple tables, usually what I want is to use pandas to aggregate my data. And then when that I have my data sets, I can start to do the modeling. The thing is that you can shoot yourself in many different ways, like shoot yourself in the foot. And because you can have data leakage or you can have categories that happen that are represented in the training, but not the testing, and then you need to handle those. So somehow you would like pandas or polars transformations, which remember what type of data that you saw during training, and is what we want to have here. So it's to provide a way to express polars pandas transformation together with utilities that you can get in Scikit-learn. So for instance, things that transform strings into numerical representation or algorithms that you want to learn at the end. So let me give an example here, very simple. So my data set is basically two things. One that is like one table that represents basket IDs and whether or not a basket is a fraud. And on the other side, I have a table where I have the basket IDs, but I can have several products for each of the baskets. So somehow I would like to merge those two informations and to craft basically some preprocessing to be able to merge them. And one that I have like one feature matrix and the target that is a fraud, then I would like to have my my modeling there. So I will launch those two processing because that may take a bit of time. But just to explain here, so what we come with is what we call a skrub.var for variables, which is one placeholder, one symbolic things that will take some data, and then we'll record every processing that we will go afterwards. So this is kind of like a tables, but then as well, under the hood, we will just remember the computation graph of what you are trained to do. And here we know that basically what we want as an X at some point will be to track the basket ID and the target will be the fraud flag. And afterwards, when it comes to put those like those pandas things and those transformation things and those Scikit-learn things together, it will play the following way. So here, for instance, we have a vectorizer, which is like the skrub vectorizer that I showed before. That will be a way to transform every data that we have in some sort of numerical representations. And at the end, we will need a predictor. So here I'm using an extra tree classifier because it's very, very fast to predict. And to get the prediction is where the magic happen in some way because we are mixing like two type of things. So here I have like, you can see it as a pandas data frame where I want to make a join or a merge with the product data. But on the product data itself, I want to apply some transformation. So here I say, I want to apply the vectorization on all column, but the basket ID. And then I want to just like reduce everything to one item by basket, basically. So, and here I take like an aggregate, which is the mean, just for an examples. And so you pipeline everything that look like really like some pandas things, and then you merge basically the two data frame together. And afterwards, I just can drop the ID because I don't need them. And then I just apply again. And in this case, this is the machine learning models to my data. And then I get my prediction. So somehow what we got here is that these successive things just recorded what are the graph of computation that we have. And then we can just like throw the data. And afterwards, we are able to replay this for testing data, which is like the advantages beyond this. And so then the second point as well is we revisited as well whatever is about parameter tuning. Because we saw that we have a syntax which is quite long with this donder everywhere, and you need to find the right name inside the pipeline, etc. We thought that it would be easier to actually get into any step inside the pipeline and have this scrub.choose from or range, give a range of value to test, or like those type of different, let's say, placeholder that will tell you what parameter you want to try, and directly pass those as parameters of the scikit-learn models or like encoders in skrub. And when that you have that afterwards, so here I again load from the data, from the disk, but somehow you have this new line that gets randomized search will actually trigger the parameter search for you. But in the definition itself, it's just much easier to like specify which parameter you want to grid search afterwards or to randomize search. So if you just do this, like run these randomizations, afterwards you can inspect basically the different parameters and what are like the different, let's say, the performance of the model in the same way that you are going to do in scikit-learn. And we provide like a couple of tools to like parallel coordinate plots to, for instance, to select or to see which combination of parameters is working. So as a conclusion, basically here is like Scrub try to bridge between databases world where you can have multiple tables to the machine learning world. Okay, so another tool that probably like I think that Gael didn't speak about. So it's called scopes. So somehow this is on the other side now is more the MLOps part of scikit-learn. So I spoke about using job leap to pickle model and then persist them and then unpickle on the production side and then use them for predicting or scoring or whatever. So usually is what we're seeing. So here I just give an example of you can train your models. Usually you use a job leap to dump the things. Later on you can load it and then you get your accuracy. The problem, which is a problem or not, depending if you know pickle or not, is that if I handle you a pickle file that you have no idea what is inside, then that can be dangerous. If you know that yourself you did it, I mean, there's no danger at all. But I mean, if it's to share with some people, then that starts to be a bit complex. So to give an example here is that pickles, one that you pickle and unpickle a file, basically you can, with the reduce function, you can just execute arbitrary code. So here I'll just give like a quick example. That's when you just load. So basically you will execute from the specific like command here. And if you have no idea who provide you the pickle and what is inside, then you can never go further, like making a simple, some type of attacks or whatsoever and write on the disk of the person or on the OS. And yeah, very many vectors basically regarding like the security issue there. So here, what we thought is maybe we can, instead of picking, when it comes to sharing like a scikit-learn model, maybe we can do improve a bit like that side. And is where scopes come into the place. So it has a very like similar API to what Pickle does. So you can dump models, load the model, and use it afterwards. But basically, the file that when we dump it, we dump as well a schematic of whatever data or like classes that are inside. And before to load, you would be able to visualize, for instance, what type of thing that you have. And seeing that we trust scikit-learn, here we have only trusted sources, so everything is blue. But to give an example of untrusted sources. I could be, for instance, someone programming my own library, and then I just have this part of my pipeline. And if I dump that model and start to visualize, because by default, this transformation here is not something that I trust, it will appear in a different manners, basically during the visualizations. Which means as well that if you try to load the model, we'll send you an error saying, oh, there's something that is untrusted. And this is this class that comes from that locations. If you really want to trust it, you can put it inside a what list, and then you trust it, and then we can load the data and we can go on with our things, with our pipelines. So here is that we add, so we have the pickling, but we use basically when we dump, we just like have a schematic of the different class that we can trust or not. A second aspect of the, let's say on the ops part, on the ML ops part, is about the ML cards. So it's a bit early for that, but somehow what we want to provide is when you pickle the models, the model is not enough. So you need to come as well with, let's say, analysis or where the model is coming from, the data that it has been trained, for what is it intended, what type of bias the model can have, and all of those. And usually this is coming with like what we call a model cards. And scopes provide already like one type of like such structure, programmatic structure, where you can just so create a card from those, and then so it will give you like a body and a template of what you should answer. So for here you put like a machine learning model, so somehow that's some HTML. So if you would put it inside HTML, you will have a nice view, and he would just like try to extract all the piece of information that he can from that model, and afterwards you have place order where you can add programmatically more information. So for instance, here, who are the authors, the description, and etc. And then depending of the model template that you can have inside the company, then you can basically use that tool. So this one is very agnostic for the moment, but we are planning basically to improve this in such features. And finally, as a last package, and so this package is much recent. Is maybe like 2 or 3 months old. So it's what we started within the company, so at Probabl. And the idea here is to take a step above and to be able to have some type of abstractions a bit more on different parts, and one specific one, which is most probably like if I can have an object where all the information about the evaluation, the data, the model can basically be all in one, and potentially the model card as well. So here I will show like a couple of things that we're already able to do, but this is really like the beginning, and we'll see further. Okay, so these things come with a score, come with the idea of a project where you will be able to persist basically reports or whatever object that you want, Python objects. So this is, it doesn't change anything compared. I mean, you could do that, let's say, with pickling if you know how to do. But here we want to have one location that basically it's surfing inside the project, and then we can help you. The vision is that we can help you as well to search afterwards the object that you might want through UI or through a notebook programmatically. So for the moment, it will be like really looking like Probabl, but like the vision is a bit afterwards. Okay, so here I will give an example of like the type of tool that we want to provide. So let's say that I have a data set, which is the employee series as before. I'm able to have a table report as what we saw before as well. I can do some scikit-learn with scrubs where I can get my model. And the first thing that we want to help people at is to having some type of report as well, but not only on the data, but like storing things about the models, the data, and potentially whatever evaluation if you want to come back afterwards. So let me run that part. It will take a couple of, maybe a minute or so. So here, basically what we do is that we are passing all the informations. Under the hood, we are just running basically the cross-validation the same way that Scikit-learn would do. But the difference is that we will try to organize nicely, basically, the information related to the evaluation. So if I request the help of that report, you are going to get only through accessor, a bit like Pandas way or Polar's way, you will get some accessor and only metrics that are meaningful for the programs that you have attained. Because here we have a regression program, so we expose you some basically some R square or RAC and some plotting as well that are related to that. One second thing that we want to provide, so here, one that you have that, for instance, you can compute one specific metric. And what we want to provide as well is when you do the expression, sometimes you just recompute always, I mean, a lot of time, the same type of data. So for instance, the prediction of the models. While you wouldn't need to do that, so you could just like, you could like avoid that part and we could only cache basically the predictions. And if you re-ask some different things, use basically the caching mechanism at some point. So under the hood, the report is doing those type of things. So here I computed my score, I'm very happy. But if you wouldn't take care, basically, if you like rerun the cell, you would expect that most probably that will just again take 20 seconds to compute this thing. And here we cache basically the results within the report and is inside the cache, and then we just load from the cache. But we can as well compute any metric that, for instance, the root mean square error will use the same predictions, and we as well cache the prediction. So even in this case, it will take like few seconds. So we will just compute, like take the time to compute the metric itself, but not request basically again some predictions from the models. And if you want to go from the beginning, basically you can ask at first, like, okay, cache me all the predictions. And then when that you are here at that stage, you could call any prediction, any metrics or any reports. And it will give you like out of the box, basically all the results that you need. So here an example of what the project can allow you to do. So we have two functions, which are, I mean, two methods, which is put and get, that can allow you to persist basically the different type of report or different type of models. So here this is to give an example. You can put the models, and then afterwards you can retrieve it and get back with new variables where you already have like your model with the cache already existing extra. So for instance, if I want to have different type of metrics in all in one, we have a report metric that basically will compute those information for you. The same way, we want as well to provide one-liners instead of spending time to matplotlib. In this case, we want to do the matplotlib under the hood to have nice graph out of the box that can work for you. And the idea is just like to provide you rich display that can have like a plot method, but as well a frame if you want to access afterwards to the data directly. But at the end of the day, that should be one line and not multiple lines to do the same plotting. So it's really like trying to find the right abstractions. So here I'm presenting like a cross-validation report, but under the hood, this is based on some what we call an estimator report, because we have an estimator per fold, and you have the same type of API for the estimator under the hood. So here I get like the first estimator from the cross-validations. You get the same type of information where you can make the plot on the first fold, and that's it. I mean, like, and you can go and basically try to find more informations. And as a last steps, we recently as well added something that can allow you to compare different estimators. So let's say that I have, so I have my first model that was histogram boosting, I think. And here I can like take the tabular learner that will do a rich CV. It will train it. I can put this inside my project, for instance. And later on, somebody can just load from the project, basically, those two different estimators that come from the cross-validations. And I can just put this inside the comparison report, and then the comparison report just will compute like a couple of missing metrics if needed. And then like give you the information about the mean and the standard deviation of each of the model, and then you will as well have access to plots and insight as well, for instance, the coefficient of the model and those type of stuff. Okay, so here the vision of Skore is really to give a bit more of abstractions and to reduce basically the amount of code that you can write for the everyday analysis that data scientists do again and again and again. So that's a bit the idea here. And basically that was the last tool that I had to present here. So now I'm just open for questions and happy to answer any questions. It was pretty dense, pretty fast. I went on the surface on so many things, but if you want like to have more details of what happened under the hood, I'm happy to answer any questions. Thank you.
Excellent. Thank you so much, Guillaume. Of course, if you're in the audience, now is your time to ask questions, so feel free to use the Q&A. In the meantime, I did want to give an opportunity for our host panelists to briefly introduce themselves, say just a simple sentence or two about what they consider themselves an expert in, and we'll dive into our Q&A. Starting off, I'll of course introduce myself. Hello, everyone. My name is Cameron Riddell, and while I consider myself not to be an expert in any one thing particular, I'm absolutely a Python advocate and enthusiast. I've been using pandas and a lot of these tools for over a decade at this point, and so it's very fun to see all of these changes and additions and adaptations that Scikit-learn has gone under. Up next on our list, why don't we go ahead and hear from James Powell. James, why don't you introduce yourself, tell us a quick sentence about what you're an expert in. And James, you might be muted on Zoom here.
Hi, everybody. My name is James Powell, and if there's anything that I hope to be able to add to this conversation, it is how do we take these incredibly sophisticated tools and convince scientific users that they're worth adopting the complexity of, the sophistication of, help them understand why it is valuable and worth their time to learn all of this complexity.
Absolutely. Well, thank you so much for joining us today, James. Up next, let's hear from Dan, then Tom, and then Phil. So Dan, why don't you tell us what you're an expert in?
Sure. I'm just a dabbler in Scikit-learn. I spend more time in traditional LM-fit curve fitting the way we used to do it. But I have dabbled in building Jupyter widgets UIs for LM-fit. So it was fun to see the Scikit-learn take on a nice Jupyter helper.
Excellent. And thanks so much for joining us today, Dan. Up next, let's hear from Tom and then Phil. So Tom.
I'm Tom Caswell, as I'm most known for being the current project lead of Matplotlib. And so I very much approve of the way those Matplotlib plots come out, and that you're shipping code that is very aware of your data structures to make nice looking plots quickly for users.
Excellent. Thank you so much for joining us, Tom. I too was also very impressed by the Tufty style range frames they had on the axes there. But Phil, let's hear from you. What are you an expert in today?
Yeah, my name is Phil Maffetone. I would consider myself an expert in ML engineering for scientific applications. So I've been doing this for a while in industry and in the government.
Excellent. And Phil, do you use Scikit-learn at all?
I do use Scikit-learn quite regularly, yeah.
Excellent. Well, why don't we go ahead and kick off our discussion? While questions come in from the audience, I am curious, do any of our panelists have a question that they want to bring to the floor?
I'll do an easy one. Does it work in IPython or only in Jupyter?
Which part? Yeah, go down.
I guess I can imagine that the interactive stuff probably does not work in IPython, but like the help screen, these kinds of things.
So in IPython, what we will do, I mean, at least, so for Skore is a bit early, but for Scrub, we want to launch basically an HTML windows, and then you have the interaction there. We don't. We have a couple of stuff with rich, for instance, inside the terminal, but when it comes to HTML representations, we want to be self-contained stuff that you can launch afterwards, like outside, but it will not in IPython directly. I mean, that's a bit complex.
Yeah, that's fair.
And building off that, I'm curious, a lot of people seem to be using Marimo nowadays. Does it have just implicit notebook support, or is the Marimo format, if you're familiar, is it substantially different?
It's a good question. I didn't look at yet enough Marimo. So here what we use is really like the standard way that it works in Notebook, but if Marimo is reused like the rep HTML, then it should be working out of the box. But I don't know if they reuse that from, or if they just implement their own way. But that's true that I would like to look at it because I really think that the way that Marimo have with like Python files behind for the versioning is something that we should maybe advocate a bit more. So at some point, is it on the to-do list? And if we can make it work, I mean, for sure, yeah, that should go there.
Yeah, it's very hard to keep up with the ever-growing ecosystem of tools where something new is popping up. It feels like every week or every month.
Yes.
Excellent.
Yes.
Any other questions, Tom?
What is it? So what do you think is or can you summarize what you've learned about exposing pipelines to users in a way that they can interact with, that doesn't just turn into either too many dots or too many square brackets that they can't keep track of?
So yes, it's exactly the point. And so for the worst or for the best, I don't know. So people that are used to bracket, then they will be disappointed by what we do. But here, so the feeling of exposing the pipeline is really, so here I really push towards something that probably Gal will be like mad at. So for instance, like having chaining operation, I know that he's screaming because he want to have, you can basically have different variables. I mean, you can cut that things, but at least that's the spirit that you can chain operations. And I have the impression that in Skore, we have been as well interesting on saying, hey, we can organize basically a rich report through accessor. That seems that people nowadays that come from Pandas or from Polars get an intuition of what those things are. So somehow that's maybe a way to go. So we try, we'll see if it works, but somehow that was, what you mentioned here is what we have behind, like in mind in some way.
I have one about a general API design question, unless somebody else has a question that they want to ask. I'm curious because you showed us a bunch of different tools that are all related, and I'm very curious what drove you into this kind of, let's say like Lego brick, where you stack tools on top of each other, as opposed to taking Scikit-learn and make it this huge monolithic empire of just one tool that you only need.
Yeah, so I think, and maybe Thomas can as well maybe tell me after that about Matplotlib. One of the UT true in Scikit-learn is that this is a 15 years old project. You have a community that goes around it. You have some type of maintenance. Everybody have a strong opinion how the API should go. And then you go very slowly. And sometimes, as you say, every week we have a new tools, but we cannot move Scikit-learn at the speed of other things that can go. And sometimes it's not a bad thing. It's just that we are not certain if this is the right API, if this is the right abstractions. So having side package that complements, and then if it is very good, either it can go back in Scikit-learn, or either maybe Scikit-learn should as well delegate some of these parts. So I will give an example for Scrub. So Scrub is really like between databases and the machine learning models and the preprocessing. And now I'm thinking, like, if I would have to start Scikit-learn today, I would probably limit Scikit-learn to NumPy and numerical operations. I mean, NumPy or array API like, so GPU involved or whatsoever, but very good at doing like learning tabular learning algorithms. And whatever is preprocessing should go in Scrub with polars or databases, backend, data frame like things, and everything could be out of core whatsoever, but it will be easier basically to make changes here. So we are not at that stage yet to make a decision or where we cut. I mean, that would be like a lot of discussion, but at least having this package on the side allow to investigate what works and to keep up as well with the new developments. And this is the same way with, so the IO part, some of the things could end up in Scikit-learn, easily, but we might as well want to have like third-party libraries to benefit directly from it without depending on scikit-learn, maybe. So why not? And score is really like the beginning of the things, and maybe there's other things as well that come with it. So for instance, the company does a product that could be related to that. So we wanted to see like if the abstraction level as well could help in some ways around that.
Yeah, I just want to add, as the maintainer of a similarly aged project that with a similar number of users, making big changes in core is scary. And like if you screw up a lot of people's day. And so doing that off in a side project is definitely good, just from like the ability to do it point of view. But I think also as you make things more fluid for some set of users, you're almost always going to make a decision that makes it worse for somebody else. Right? The really cranky explicit API that isn't magical for anyone but works for everyone is a different API than the one that is magical and terse for a subset of your users. And I think the example I like to hold up is Seaborn, right? If you have tables and you want to do statistical plotting, like please use Seaborn because it is tuned for that problem. But if you have images, like Seaborn doesn't help you at all.
Yes, I completely, and that's really like it's a bit what score bring on the table. I mean, we're interested about an evaluations and to understand your program, and then because we have this, we can make the right view because we know you try to compare two machine learning models. So we will use matplotlib in these specific settings, showing you that specific information out of the box. If you have general tools, you have all the building blocks to do it yourself. But somehow it's like, okay, give me a bit more, I mean, to make this, but it cannot be used for other stuff. I mean, this is like, it's really limited in what you want to do. But if it does a good job, I mean, that's nice.
So I have a follow-on question, because I think that's a really important point, right? That generic tools make a lot of people's lives very easy, while having the specific APIs makes a lot of technically complicated things very achievable. Let's imagine I have a giant code base of scikit-learn automations and pipelines set up. Do I think about migrating that to Skore? Do I think about adding new things, maybe using Skore? What is the burden, the overhead? Is there a really big value gain, or is Skore something you want to do when you're doing something new for the first time? And if your automations already work, unless you really miss the harmonization of the plots being the same.
So on Skore particularly, so this is really the beginning, but is to give an example of where we are heading to. And I will say, no, you should not change stuff. The idea is that we see that people, for instance, might have already a registry with ML flow model with some scikit-learn model there. So what we want to do is load your model from there, give it to us, and we have an sort of integration, and we are able to consume those and give us, I don't know, a DVC with the data somewhere else. And then at least you will have the scoring part, like the evaluation part, that you can maybe like inspect part of this without to change the full things. Then if you start from scratch, okay, we give you like, okay, start from scratch and use all the tool. But we want to have integration with what exists. I mean, that's really important. Because I assume that, I mean, you will not be happy if you need to like redo every 6 months a new things.
Right. Yeah, I think that's a really good point. I mean, especially I won't speak to how we do things here, but in the context of storing historical models, right? The way models get thrown into a bucket and kept there forever, that really doesn't change much. So being able to bring them back in and say, well, now I have a new way of doing a new model, and I need to do some comparisons. Like that's very easy, I think, bolt on to say, how do I pull this into the system and integrate it into the comparison framework?
Yep. So integration is key, I assume.
Yeah.
Any other thoughts from our panelists here?
I'm interested in learning more, but in case anyone else listening has tried to go to the website, it looks like the BNL firewall is suspicious about that cool probable.ai URL. So maybe folks at other labs might have the same experience. We can look into that at Brookhaven.
Okay, that's interesting.
Government firewalls are always
Yeah.
so so great, so great.
I think it's just too trendy, Guillaume. It's not your fault.
Too much traffic.
Did you learn anything about the Jupyter widgets ecosystem through building the visualizations or the Repr HTMLs that surprised you or is worth noting?
So here, there's something that is not yet, I mean, we are going to ship as a next feature. But somehow I use a bit of Jupyter widgets because I wanted, so let's say that we are able to put many estimated reports. And at some point, we want to give a way to be able to filter some of those reports to be able to create a comparison report, for instance, with things that work well, etc. And then we combine a bit of Jupyter widgets to be able to have like some widgets with a parallel coordinate plots that allow you to add dimensions and to have, and everything is a data frame because this is metadata, but like the representations is actually a widget. And then you can interact with it like this. And then having like let's say something to say, okay, I make my selections and now I'm going back to programming and say my data frame dot reports and get my report out of it. So we are planning to have a bit more widgets because we are interested really to be able to work in notebooks in an interactive manner. So for the moment, there is few of them, but it will be more. So we have only the progress bar, I think, for the moment. But we already have a second one that comes, and later on we will add more and more. So, for instance, for the the helper right now, this is a pure like rich thing. So it is great
Repr
like Python.
HTML.
But we would like to have like a more modular, maybe that you can click on stuff because you want to fold some of the parts out of the box. I mean, like, and then people are going to check because otherwise it will be overwhelming. So we are going to trigger like the Jupyter world for that, and then expect that people that work in VS Code can benefit from it as well.
Thanks.
Time for one, maybe two more questions if our panelists have anything additional, thoughts or otherwise. All right. Well, if there are no other questions, then let's go ahead and adjourn. This wraps up this month's session of the Python Exchange. I want to thank our audience for joining us today. This has been such a blast having you all here. And of course, I need to thank Guillaume for joining us. Guillaume, this was such a fantastic discussion because honestly, I didn't know that most of these tools existed outside of Gail mentioning them the other month. So it's excellent to see them all in one cohesive demonstration. And for everyone joining us, don't forget to check out the Scikit-learn ecosystem for these tools for your next machine learning project. Now, I will mention next month, we're going to be joined by Kyle Sundin. Kyle Sundin's a research software engineer with Matplotlib, and will share some new Matplotlib innovations titled Dynamic Data with Matplotlib. So keep an eye out on our website, that's meetup.doepy.org, to stay in touch with dates and times for that particular meeting. Thank you all for joining, and I hope to see you again next time. Thanks, everyone.